Welcome to Algebra 2, Unit 8, Section 3, Trigonometric Functions. I realize that the goals for the lesson are incorrect on the handout and here, but we'll go through this and you'll figure out that those aren't what we're using right now. So we're going to be using trig functions. Okay, so what is a trigonometric ratio? Well, the word trigonometry comes from two Greek terms, trigon meaning triangle and metron meaning measure. So a trigonometric ratio is a ratio of two sides of a right triangle. One trig ratio of triangle ABC is AC over AB. Okay, so it'll be the length of this leg here over the hypotenuse. Okay. And one of the things we're going to do here with this, just to illustrate how this is going to work, is if we take and we draw on a little line here, looking like such. Okay, so we have a length, all right, a ratio. Let's say that this length here is 10, okay, or let's not even go there with it. Let's just say that this is an AC, the length of AC, that this is 1/2 of AC. And it would make sense that this length here would be 1/2 of AB. Well, they're still in the same ratio. And that's related to this angle, this 35-degree angle. So by angle similarity, which is a geometry concept, a right triangle with a given acute angle measurement is similar to every other right triangle. Therefore, trig ratios are constant for any angle measurement. So triangle ABC is similar to triangle FGH, is similar to triangle JKL. So we would say then that there we go. AC over AB would be equal to FH over FG, right? And that would be equal to JL over JK. Okay. So that's what you put in there. So the sine, all right, if triangle ABC is a right triangle with acute angle A, then the sine of angle A, which is written as sine of A, is the ratio of the length of the leg opposite angle A, opposite to the length of the hypotenuse. Okay, so this is equal to the opposite of the hypotenuse, opposite of angle A. Well, if we go opposite of angle A, that would be A over C. Again, opposite over hypotenuse. Okay. And this would be B over C for angle B. Okay. Now, if we take a look at this trig function relative to the standard position, which is in the first quadrant of a Cartesian plane or the XY plane, and we have a ray going through from point A to point B, we create this triangle here. B is at point XY. This is what we call R, or just because it'll be like a radius of a circle. And we drop down here, we have a right triangle. So the sine of A is equal to this length, Y, all right, over the length of R, right? And this is called, this part here, this stands for the reciprocal of the sine, and this is called the cosecant. Cosecant. That's what that stands for. Now the cosine of triangle ABC is going to be equal to the adjacent length over the hypotenuse. So we would write this as adjacent over hypotenuse here. In angle A's case, that would be B, the length B over C. And again, adjacent over hypotenuse for B, it's the same ratio, but in this case it would be A over C. And in the case of a right triangle based definition of this, right, if we were using the same first quadrant, which shows up a little better here if I reduce the size of this, right? This is called the secant. The hypotenuse, the reciprocal of the cosine is called the secant. Okay? And there's our symbol down there. There's our drawing. Secant. Okay? Same diagram from before. The last trig function we're going to talk about is the tangent, and it's the opposite leg over the adjacent leg. So this is opposite over adjacent. In this case, that would be A over B. And opposite over adjacent for tangent of B would be B over A. Now, here is the additional trig function. This is the cotangent. Okay, cotangent. It's just the reciprocal. Alright. So, the secret code word of geometry, and this actually should be of trigonometry, and that is SOHCAHTOA. So sine is opposite over hypotenuse, right? S-O-H. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, right? SOHCAHTOA. This word is important that you memorize it because you're going to use this, right? So let's go through this, and it says express each ratio as a fraction and as a decimal to the nearest hundredth. Okay. So the sine of P is the opposite over the hypotenuse. So this would be equal to 15 over 17. And we take out our calculator and we divide 15 divided by 17, and we get 0.88. The cosine of P, adjacent, cosine, 8 over the hypotenuse is 17. What's this approximately equal to? Well, we take 8 divided by 17, and we've got 0.4705, so we're going to say 0.47. The tangent of P P? Well, the tangent of P is the opposite of P, which is equal to 15 over 8. So 15 divided by 8, 1.875 was 1.875. Okay? Because we didn't round that. That's why it's equal. Okay, now let's do the sine of Q. Well, the sine of Q is the opposite is 8 over the hypotenuse is 17. 8 over 17, which we figured out earlier is 0.47. Okay? The cosine of Q is 15 over 17. And we plugged that into the calculator earlier and got 0.88. Then the tangent of Q is equal to 8 divided by 15. And that we have to calculate. 8 divided by 15. And we get 0.53 repeating. So it's 0.53. And we can put repeating. You should notice that the sine of P is equal to the cosine of Q. And the cosine of P is equal to the cosine of Q. And that the tangent of P and the tangent of Q are reciprocals. Alright, so we're going to solve for some stuff here using a special right triangle, which is 30, 60, 90. And they want us to find 30 degrees as a fraction and as a decimal. Alright, so we're going to solve sine, cosine. Alright, so the sine of 30, well, that's going to equal opposite over hypotenuse, right? And here's the thing, to identify the hypotenuse, it's always opposite the right angle. So here's their hypotenuse. Okay, so opposite over hypotenuse is equal to x over 2x, and that's equal to 1 over 2. The cosine of 30 is equal to x over the square root of 3 over 2x. So that's going to equal the square root of 3 over 2. The tangent of 30, well, that's equal to opposite, which is x, over x square root of 3, which is 1 over the square root of 3, which, as we talked with radicals, you need to clean that up. And that becomes the square root of 3 over 3. Now, one of the interesting things is that what happens with the when we do 60. So let's do sine of 60, cosine of 60, and then the tangent of 60. Alright, so the sine of 60 should be equal to the cosine of 30, right? So that's going to be the square root of 3 over 2, right? The cosine of 60 is equal to the sine of 30, which is 1/2. Right? Now we get into something interesting, which is the tangent of 60. So that's just x over the square root of 3 over x. So it's just going to be square root of 3. Alright, so now we're going to do some work solving for some values. So let's solve for x here. So I know that the sine of 25 is equal to the, oh, excuse me, we're not going to use sine. Wrong trig function here. First of all, here's the hypotenuse. I've got nothing. Across from this angle is an opposite, and here's the adjacent. So the only place I have to work with is with the adjacent and the opposite. So I'm going to use tangent of 25 is equal to x over 18. So I'm going to use some algebra here. I'm going to multiply each side of this equation by 18. And I get 18 times the tangent of 25 is equal to x. So here's the calculator becomes a very handy tool here. So 18 times the tangent of 25, and I get 8.39353, and we'll go to the nearest tenth, so this is equal to 8.4. Right. Okay. All right, first thing let's do is label. I've got across from here is the hypotenuse, and right here I am adjacent, right? I'm right next to the angle. So the code word that would fit here is cosine, C-A-H, right? So the cosine of 70 is equal to the adjacent 15 over the hypotenuse x. So just as a little side note here, because we're going to do a little mathematical trickery that we can use, we know that if I have 6 divided by 3, that's equal to 2, and 6 over 2 is equal to 3. So we can basically switch these, right? You can switch them in and out, and that's still going to be true. You'll still have a true mathematical statement. So because of that, I'm going to switch these two values here. I'm going to switch x and cosine of 70. So I end up with x is equal to 15 divided by cosine of 70. So take my calculator. 15 divided by cosine 70, and I've got 43.85. so this is going to be, x is going to be approximately 43.9. Alright, so if we know the sine, cosine, or tangent of an acute angle, you can use a calculator to find the measure of the angle. Alright, so basically how we do this, we just use different notation. So if it's sine, we say inverse of sine, we use sine -1 of A equals measurement of angle A. If it's inverse cosine, it's cosine -1A equals measure of angle. A, and then if we use inverse tangent, we use tangent -1 of A equal to the measure of angle A. So let's put this to practice. Okay, so they want us to find the measure of angle A to the nearest tenth. So we know then that this is opposite, right? Here's the hypotenuse. I've got the hypotenuse, and I've got opposite, and this helps to label it. So I'm going to set this up as sine -1 of opposite, which is 18 over 27, is equal to angle A. So we take out our calculator, and above the sine key, by using the second key, I hit sine and I get sine -1. And then we just put in 18 divided by 27. 18 over 27. And we hit enter. And I've got 41.8. Alright, let's do another one. We're going to find the measure of angle A again. Again, it helps to label things. So here's my hypotenuse, here's opposite, and here's adjacent, right? And here's angle A. And of course, we're going to have to work with opposite and adjacent, which is tangent. So tangent -1 is equal to the opposite, which is 6, over 20. And that should give us angle A. So I take my calculator and I punch that in. Second tangent, 6 divided by 20. 16.7. Okay, last one here. I have a hypotenuse here. This is across from here, right? There's this. This is the hypotenuse. This is adjacent. This is opposite. I got nothing in opposite, so I am going to use cosine. So cosine -1 of 3 over 15 is equal to angle A. Second cosine, 3 divided by 15, and I've got 78.5 equal to angle A. Alright, solving a right triangle. This is not as hard as you might think. Okay. So the first thing we're going to do is we're going to get this side solved for right here. Okay. So that is the hypotenuse. Right? This is the hypotenuse. So we're going to use Pythagorean theorem to solve. So 5 squared plus 9 squared equals, we'll say x squared here. So I've got 25 plus 81 equals x squared. So 25 and 81 is 106 equals x squared. Take the square root of each side. I get the square root of 106 equals x. So this is equal to the square root of 106. Now we can choose any angle we wish, right? We know z is 90, so that's not anything to do anything with that. but x or y. So we could choose x or y, and we can choose any of the trig functions we wish to use. So I'm going to start with angle x. Let's take angle x here. Okay. And before we do that, let's do square root of 106, because I just realized we have to put that to the nearest tenth, and that's 10.3. So 10.3 is approximately the length. Okay, so now let's go back to our conversation about this triangle. So we're going to do angle x, and it's going to be sine or cosine or tangent. And I'm looking at 5 and 9, and I'm going to take I'm going to use tangent. So the tangent -1 of 9 over 5 is equal to angle x. So we go ahead and plug that into our handy dandy calculator. So second tangent -1 of 9 divided by 5, and we get 60.94, and we're going to round that to the nearest degree, so 61 is equal to angle x. Well, if angle x is 61, angle x and y have to add up to 90, so that makes 29 is equal to angle y. Now, just to show you something, if I had, let's say I'd taken and gone with the sine of x, I would have gotten the same exact value, right? Second sine of x of 9 divided by the square root of 106. And I would have gotten the same exact value. So it doesn't matter what trig function you use. And then you just subtract what your angle value is from 90. And you can solve for that other angle. Oops. Alright. Let's do this one. Alright, so we are given the hypotenuse here. So here's x. We don't know what x is. That is a leg. So x squared plus 5 squared equals 13 squared. X squared plus 25 equals 169. Subtract 25 from each side, I get x squared is equal to 144, and if I take the square root of each side, I get that x is equal to 12. Alright, so this is equal to 12. I can choose any angle I want. I'm going to go with angle G this time. Okay, I'll go with angle G, and I'm going to go with sine. Right? So the sine -1 of 12 over 13 equals angle G. So get our calculator out here, not that, this, and second sine -1 of 12 divided by 13, and I've got 67.38. So angle G is equal to 67, which makes angle F 90 minus 67 is 23. And we're done with that one, at least. Alright, here we have another one. Okay, so in this case, I don't have to do anything, but I can solve for this angle right here. This is 28, right? Okay. So now I have to solve for one of these sides first. Okay. This is, let's figure out what side this is. This is the hypotenuse. So since I have a hypotenuse, I have to pick either sine or cosine. So I'm going to hit cosine this time. So the cosine of 62 is equal to, well, if we do cosine, that means we got to find this adjacent here. So in that case, we're going to use the adjacent, which is AB, the length of AB, over 10. So I'm going to plug this in. Well, actually, I'm going to do my algebra first. I'm going to multiply each side by 10. And I get 10 times the cosine of 62 equal to AB. So we're going to do that now. 10 times cosine 62. Let's close that parentheses. Boom. 4.694. So that's going to be 4.7. So 4.7 equals AB. Now we can do the same. We can use the sine of 62 to solve for BC. Or you can use Pythagorean theorem. I'm going to use the sine of 62. So sine of 62 is equal to BC divided by 10. So 10 times the sine of 62 equals BC. Right, I just multiplied each side by 10 here to get that isolated. Right? So 10 times the sine of 62. And I get 8.8. So 8.8 equals BC. Right? So you can check your work with this, okay, by saying 4.7 squared plus 8.8 squared. And we end up with 99.53. But using my graphing calculator, I could actually go up and do this and hit enter and then hit squared and then plus, let's go all the way up to this one and hit enter and square that, and lo and behold, we will end up with 100. Okay, because we rounded off, we were off by almost a half, right, by 0.47. Okay, 30, 60, 90 triangles. Now, if we take a 30, 60, 90 an equilateral triangle and we split it right down the middle here, all right, right smack dab, right down the middle, we cut this. We end up with two triangles, one here and another one here, and those two triangles all have these 30-degree angles. They have one angle is 30, this one is 60, this one is 90. So if we go to solve for x, what's the value of x there, the length there? Over here we already have it, by the way, it's square root of 3. Well, let's prove it though. So 1 squared plus, let's say, x squared equals 2 squared, right? So this would be 1 plus x squared equals 4. Subtract 1 from each side, x squared equals 3. Take the square root of each side, x is equal to the square root of 3. Okay, so we've shown that in 30, 60, 90 right triangles, the ratio of the sides is 1 to square root of 3 to 2. Okay, And these are called special right triangles. 30, 60, 90s, and these are all the trig functions for that. Right? And this will come in handy later as we work on some other ideas. The 45, 45 right triangles is if we have a isosceles right triangle. Okay, what is the value of the hypotenuse? Well, you can see right here they've already got this figured out, but we'll show the work, right? So this would be 1 squared plus 1 squared equals r squared, right? So which is 1 plus 1 equals r squared. 2 equals r squared. So the square root of 2 is equal to r. So the ratio of the sides of a isosceles right triangle 45, 45, 90 are 1 to 1 to the square root of 2. So you're going to end up with a bunch of square root of 2 stuff in all of your trig functions dealing with 45, 45, 90s. Right? See all that square root of 2? Alright, and 1. Okay. The tangent and cotangents are all equal to 1. Alright, so there's this table here in your notes, and you're going to see this symbol here. And then now you become part of a very select group because you'll know what this is. This is called theta. And what's theta? Theta is just a variable used for angles. Okay? So they use this symbol, and that is how we know you're looking for an angle measurement. It's not, it's a variable. Theta is a Greek letter, so okay. So that concludes today's lesson on trigonometry. Hope you learned something new. Have a great day. Peace.